Hello and welcome to update number 1 of Zig Clr. So first of all, I want to talk about the updates that I've made to the modified Zig compiler. If we take a look at error.zig, what you'll see is a few more types here: init, dinit, generate, mir dinit. And these are basically functions that the bound in library will have to implement. And by implementing them, you'll be able to hook them up into this DLL struct, which is globalized here. And that's how these are the function call hooks that currently are needed. I still will need a handful of mirror analysis functions, and also the architecture of how this works may change in the future. But just to give you an idea of what sort of things you need to start to support in order to fully get everything up and running. So that's the modifications to the Zig compiler. And I do also want to show you that I have made some changes to the clr.zig itself. And specifically, let's take a look at this generate implementation. And what the generate implementation of generate is going to do is it's going to look specifically for the main function. And when it finds the main function, it's going to print the AIR instructions for that. I've gone ahead and written out a run1.sh shell script, undefined use before assign.zig. So let's go ahead and run that. And what you can see is it has gone ahead and during the generate stage, you can see it's still doing this linking stage. It's gone ahead and printed out the AIR instructions. So this is what the AIR instructions for this case looks like. And let's look at the code. It's basically just create a variable, set it to undefined, add 1, and then return the result. Now what you notice is that unfortunately, since I'm just dumping everything to standard error, there's going to be a couple of weird things that show up. This is not a reliable dump of anything. This second instruction should just be alloc. This nick extra anon 3020 is just junk that happened to be coming through standard error at the same time as this got printed. So if you take a look at the compilation process, the Zig compiler will dump a bunch of things to standard error. And so this just happened to be there for the ride. Same with this analysis word here. That shouldn't be there. It should just be dbg statement. But since this is going to be a debug function, we're not actually going to be parsing any of this stuff. It's just something that I think it's okay to live with for now. Right. So what we have now is a system where we are passing the AIR to the library that's dynamically loaded. And then what are we going to do with it? So if you notice, I've created a somewhat unusual directory structure here. There's a test directory, cases, integration, and then there's this undefined.bat. So let's take a look at this. So if you've ever worked with bats, what this is, it's a testing suite for bash. And what I've decided to do is to wrap all of the integration tests in bash. Why is that? The working plan right now is to have Zig Clr be a transpiler. So it's going to take Zig code. It's going to read the AIR coming off of the Zig code and transpile the AIR into Zig code that will itself perform the analysis. The reason why I made this decision was because I decided that I didn't want to deal with all the asynchrony that happens inside of the Zig compiler. What I didn't want to do was to, for example, start analyzing a function and then stash the result in some sort of payload, and then actually wait until that code is called, that function is called by another function, which may come in order or out of order, and jump into that and do the analysis then, versus or what if like we make a call and then that call is not taken care of because the call that it makes, the function hasn't been converted into AIR, then we have to put a pin in it and then suspend the process of analyzing that and then return to it when the callee is being processed and just complete everything. All of that sounded like too much of a hassle. It was very easy to do in Elixir with the Beam ecosystem because the asynchrony is like a very easy to deal with. I just decided that, you know what would be better if we just generate a function per function, and each of those functions effectively does the analysis of the function as of runtime during its runtime. But when we create the compilation, we should have all of the functions existing. And so when we do a second pass of the compilation of the compiled Zig file, all of our dependencies exist. And the only thing that we can't really do is deal with a caching might be a little bit difficult, and to deal with recursive function calls, which would have been a problem anyways in sort of the in the interpreted during the compile time strategy. So I have decided to make Zig Clr be a transpiler instead of an interpreter. Okay, so that is the update for update 1. I'm pretty confident that this setup will enable me to like move really quickly and really be able to like run through integration tests fast. You'll also see like a claude.md. So all of the stuff in the Zig Clr, I'm going to be going through all and generating the code and inspecting them, but they are all going to be generated with a lot of AI assistance. I think that'll enable me to actually have a shot at finishing this by the end of December, or if it has to bleed over into January, not bleed too much into January, because like I think reading through Claude so far has been very good at helping me read through like parts of the Zig compiler. Not to worry, everything inside of the Zig directory itself is forbidden. So let's see, do not modify the Zig submodule. I don't think that I'll turn this into a PR that goes into the Zig Zig compiler itself. But just in case I do or somebody else wants to down the line or take what I've got and make modifications, make it more robust and give it more tests, PRing into the Zig compiler is certainly going to be a possibility because there won't be any AI involvement in anything inside the Zig directory itself. And hopefully, like what I build into the modifications of the Zig compiler will be a reasonably general set of utilities that somebody building a custom compiler backend would want to build. All right, so that is it. Next update, I should have integration of the linker and calling functions through the linker, and I may actually decide to refactor how the initialization works. So see you next time.